On today's Retro Tech Repair, we're going to be trying to fix this Casio alarm clock that I bought spares or repair on eBay.
So I don't think this is going to be a particularly taxing repair, but hopefully it's an interesting item, so let's take a look at it. Somebody's got some eBay tape, I see. And nicely packaged, a little bit yellowed, perhaps a bit smaller than I expected. Yeah, it's a Casio clock. Seems to be in nice cosmetic condition, no scratches or anything like that. Quite yellowed, a little bit smaller than I anticipated from the photo. Display looks to be good. If I remember rightly, this had crusty battery contacts on the listing. Let's take a look at the listing before we go too much further. And here is our eBay listing, Casio Alarm Quartz Clock DA-204. Spares not working. I paid 99 pence and £3.20 shipping, so just a little bit of fun with this one really. And here is the full description, short but sweet. Casio Alarm Quartz Clock DA-204, spares not working. Looks like the batteries were left in, so the springs need looking at. So let's take a look at those springs. Well, the battery compartment itself is pretty tight. Very tight, in fact. To the point that I'm looking to see if I'm doing anything wrong, and I think maybe I am. It looks like it goes downward. Yeah, the arrow is pointing that way, so that's unusual. And there it is. Oh yes, and indeed the battery contacts do need looking at. They are quite crusty, but are they intact? No, we've lost a spring at this side, unfortunately. Okay, well, let's see what we can do. It looks like to get inside, we just have one screw here. There may be some more hidden under the feet, but we'll see. It certainly hasn't just kind of leapt away there. Let's take a look under these feet and see if there's anything under there keeping it in place. Well, they've both come away. So they want to come away anyway, but no, I don't think there's any feet under there. It looks like there is a little bit of a gap right here, so I'll see if I can get a kind of spudger in there and split this open. Ah, easy when you know how. All right, so looking at this, it looks like the positive terminal is brown and the negative terminal is red. Red's a bit of an unusual colour for the negative terminal, so I'll probably need to be a little bit careful with this when I connect it up to my bench power supply. I'm not quite sure how I'm going to do that yet. Maybe I'll get some clips on here and see if we can get some contact. And with my bench power supply set to 3 volts, we'll power it up. Nothing. Let's try again, make sure these are making contact, because I don't see any current draw from my bench power supply. I'm pretty sure this is making contact now, and there's nothing on the display, so we're going to have to dig a little bit deeper into this one. Alright, so we've connected the bench power supply straight onto the wires now, and still there's nothing on the display, so the battery compartment wasn't our only problem there. There's obviously something going on the main board that we need to look at too. I did spot some corrosion here, so maybe we need to dig deeper there and see what's going on. There we are, we have quite a lot of corrosion in this area here and maybe elsewhere on the board too. I think it might be easier just to separate everything out here. This of course is all very fragile, but what this means is now I can work on this without risking kind of the weight of the plastics pulling on the board as I'm trying to clean it. So we'll start off getting this cleaned up with some IPA and then we'll give the board a visual inspection. And I see already it does look like we've potentially lost some tracks here. And in fact, it looks like we may have lost quite a few tracks. Alright, so I've got rid of quite a lot of the corrosion, but there's still quite a few tracks and pads there that are fairly heavily corroded. So I'm just going to gently brush some of those with the fiberglass brush. We've already lost some printed circuit tracks on there, so I don't want to rub those away. I need to be able to see where they go. I might also remove this sounder, which is feeling quite fragile, but Let's start on these tracks first. And just gently lift the display out of the way so we can get in here, get at those contacts.
So while I unsolder the speaker, and before we get into the horror that is the printed circuit assembly, let's take a look at the plastics. And so everything gets thoroughly cleaned with window cleaner and a toothbrush before being dried with a microfiber towel. Next, I mask off the display panel with some masking tape before carefully applying some hydrogen peroxide gel and then sealing it in an airtight container and leaving it somewhere warm.
So looking at this printed circuit assembly here, there's quite a lot of corrosion evident. There's significant corrosion to the printed circuit assembly tracks and also to the solder joints themselves. The extent of the corrosion is such that it's a little bit difficult to tell whether electrical connectivity has been maintained, but it does stretch in some areas through a significant proportion of the board, perhaps further than I would have anticipated, and we still see corrosion on the tracks all the way up to the microprocessor. So I was going to buzz this out with the multimeter, have it on continuity check here, but I have a little bit of a problem. When I touch either side of these contacts, they're so corroded, the solder joints are so corroded that even when I'm actually touching the joint itself, see if I touch the probe it's fine, but when both probes are on the joint, there's no continuity there because there's so much corrosion on those solder joints. So what I'm going to do is I'm going to unsolder, reflow, resolder these joints, and then hopefully we'll be able to buzz out on the board and see what's going where.
So I applied some flux to the corroded solder joints, I reflowed them with some fresh solder, and then I cleaned everything off with some IPA. I also took the opportunity to solder in some more sensibly coloured wires for the connections to the battery.
So now with my meter on continuity test, I can start to look for these broken tracks, but there's quite a lot of damage to this board, and if I start with the positive here, trace it through by eye, it's supposed to arrive at this solder joint, which it does not, and it's supposed to arrive over here, which it does not. So the positive supply obviously isn't getting very far from where it enters the board here, and it's certainly not getting to the two places that it's supposed to be reaching. So I could just put wire links in where things are missing, and I might end up doing that yet, but I wanted to try and clean it off with this fiberglass brush so I could maybe see where the damage has occurred. It'll give me some indication of where I see similar damage elsewhere on the board, whether it's likely that I've lost a track or not. And I've put some paper in place because these fiberglass pencils leave little shards of fiberglass around, and you really don't want those getting in your fingers or anything like that.
So having exposed the damaged track, I was able to reconnect it using a solder bridge to the nearby pin. Unfortunately, I forgot to film it, but not to worry, because as we will soon see, there are more track repairs yet to come.
Well, unfortunately, I neglected to film it, but it does now contact the next pin along. So with power going this way, what about the other side of the board? No, it's still not found its way over there, so presumably there's some damage on this track somewhere all the way around.
After a little more work with the fiberglass brush to remove the solder mask, we can see what's going on.
So as I bring the microscope in here, you're going to be able to see where that track was damaged. Let me get this lined up, and there we are. Move that back a bit. So there you can see, hopefully, that the track has more or less been corroded away. It's thin in places, but then in one particular spot, or a couple of particular spots, it's clearly broken entirely, so we need to do something about that. And what I'm going to do is I'm going to try and repair it with something like this, which is enameled wire. So I've decided to clean off some of this wire with a piece of sandpaper. Now this is enameled wire, so if I was running it across the board and I didn't want it to contact anything else, I wouldn't clean it off. But here I'm just going to go over this one little track, only about so long. So I'm just going to clean off the whole length, and I'm going to do that with a little bit of fine sandpaper. I think this is 0.2mm wire, and I think this is, oh, I don't know what this is, 800 grit, something like that. All those people who repair cars for a living will know that 800 grit actually isn't that fine.
So thanks to the magic of television, that all seemed a little easier than it was. But in real time, it took me a couple of minutes, and if I was to show you each repair in that level of detail, we'd be here quite a long time. So I know the clock isn't working, but I'm just going to check that I've got voltages going where I wasn't before and where I think I should have. So I have 3 volts coming in from my bench power supply here, and I'm just going to take a measurement here to show the 3 volts coming in. I had the probes the wrong way around, so let's do that one more time. Should be 3 volts, not minus 3 volts, of course. Yep, 3 volts there. And we'll check again to the track that we repaired. And I have 3 volts there, and all the way over here to this side on the board. It's a little bit of a corroded contact, I think. Yes, and I have 3 volts there as well. So I do have the 3 volts finding its way across the board now, which I didn't before, but of course the clock still isn't working. So it turns out I have tracks all over this board in need of repair. This is the next one that I found. It's supposed to run from here to here, but it doesn't. And then it goes on to elsewhere on the board, which it does make. There we go. But it's not making it from here to here. So I guess we need to repair that too. So looking at the connection more closely now, it is making a connection between this pin and the track right the way over here. But that track isn't making a connection to this solder joint. I don't see any damage to the pad, so I think I'm just going to unsolder this with the desolder tool and then resolder it. And so not visible to the naked eye, even with a loupe magnifier, which of course wouldn't be the naked eye. If we look on the microscope now, you can see just a tiny crack where this pad meets that track. So I think I'll just bridge that with some solder when I resolder that part in. And as fiddly as that was, it did do the job, but it wasn't our only problem. It looks like we have a damaged track here, and here, also here, and here, and here. And after I found about 8 or 9 of these breaks, I stopped filming them, but I kept finding them, and I did repair them. Now, it's not my best work, I have to say, but ultimately it was all about getting connectivity back across this board. And after that, it's out with the green nail polish to cover the monstrosity that I've created. And so here is our finished board, and I can't say I'm particularly proud of it. It does look quite messy, and although the nail varnish has covered a multitude of sins, it still looks quite unpleasant. I feel like I could have done a better job of this, but hopefully I've made all the connections and it's going to work. We're going to put it back together and we're going to see. So because this is an LCD display, it has a polarizer, but the polarizer that we have in any orientation doesn't seem to be polarizing anymore, so we're going to have to replace this with something. This is a replacement polarizer for an iPad. It has a protective film on it at the moment, but as I put it over the display and turn it, you can see in some orientations like that one, the display is clear, and then in others, the display goes really, really dark, and we have to find the right orientation for this polarizer. Kind of diagonally seems to be about the best, so that's what I'm going to do. But I'm just going to draw around the polarizer that we have with it, roughly 45 degrees. This, of course, as I say, is the protective film of the iPad polarizer, so it doesn't matter too much that we're drawing on that. By this point you've probably realised that I've taken the plastic parts out of the peroxide gel and I've rinsed them off. Unfortunately I didn't film that, so you're going to have to take my word for it that the plastics are much whiter than they were before and there's no visible fading to the graphics. So after I'd reassembled everything, I decided I wanted to replace this capacitor. Now, the problem with that is that there's a lot of rework gone on the other side of the board, and one of the tracks that I have had to patch up runs straight across that cap. So I really don't want to unsolder this as I would ordinarily. Normally I'd just desolder it, put a new one in, and that would be it. But because of the way this is assembled and because of that way I've had to repair that track, I think what I'm going to do is I'm just going to cut it off here and solder a replacement in by tacking it onto the existing leads. And there we have it.
So let's get us back to where we started on our crusty contacts here. I have here a replacement spring that I bought on Amazon, but it's just a general purpose one. It sort of fits, but it's a little bit too big, so I'm just going to have to trim some off the edges here to get it to fit. Well, it didn't slot right in, but we got there in the end, so I suppose that's going to be okay.
So hopefully there's not too much left to do now. I just cut the wires to an appropriate length, solder them to the battery terminals, and then reassemble everything, ready for final test.
So here is our finished and working alarm clock, and what a charming little thing it is. Let's take a look at what it does, and I'll talk through some areas where I don't think it's doing quite what it should be doing. So if we start off then, it's basically an alarm clock. We have an alarm function here. With the alarm off, there's no indication of the alarm on the display. With it on snooze, we have the snooze and the alarm indicator, and then we move it again along and we get the alarm indicator only. We can set the alarm time. Currently it's set for 9:01, and here's the curious thing. If I wanted to increase that, I'd expect to press this button, but in fact that moves it earlier. And then if I press this one, the downward button, to me at least, that seems to advance it, which isn't quite what I would have expected. If you hold it for a little bit longer, then it advances more quickly, and the time set function works in exactly the same way. So I'm not sure what the adjust set button is for. I've pressed it, it doesn't really seem to do anything, and I can set the alarm time and the clock time easily using this switch without pressing that button. Other than that, it seems to work fine. It has a charming melody. I'll play it all for you in a moment. Oh, I have to turn it into the normal setting first. So we'll go through that towards the end of the video, but that's just about it really. But I think it's quite a charming thing. We have two witches, I assume they're witches, they're kind of flying around a house there, being watched over while they play on a seesaw by their cat. I can't imagine that there are many of these left, and I know it's perhaps not a video game or a video game console or something exciting, but it's a little piece of history that I think if I hadn't repaired it, we might have lost.
And as you've probably guessed, that just about wraps it up for today. I hope you've enjoyed the video, and that if you have, you consider hitting subscribe. But until next time, I'd just like to thank you so much for watching Retro Tech Repair.
And off we come with the lid.